Okay, so my name's Amar, and I'm going to be doing a video partner review for Chapter 8. A few people had requested this, and they know who they are. And, yeah, let's get started. So this is problem 1, where you get side length, A equals 7, angle measure of the angle A, which is opposite side A, is 25 degrees, and angle B is 23 degrees, and you're looking for side length C. So start with this triangle. Angle A, angle B, angle C. You're given side length A is 7, and angle A is 25 degrees, angle B is 23 degrees. And knowing that the sum of the angles inside a triangle are 180, you can find that the third angle is 132 degrees. Now, you want to use the law of sines here because you're given these three angles and a side. And law of sines says that the sine of one angle in proportion with the opposite side is equal to the sine of another angle in ratio to the opposite side of that angle. So we can say and vice versa. So 7 over the sine of 25 is equal to this C, which we're looking for right here. This is the C, the side length C that we're looking for, over the sine of 132. So then we can multiply them both by sine of 132. So C equals sine of 132 times 7 over sine of 25. You want to put this in your calculator and make sure that you have it set to degrees, otherwise you'll get a funky answer, I guess. And if you do that, you get C is approximately equal to 12.31. And just a quick way to check your answers to see if they're reasonable or not. The side opposite the largest angle is going to have the largest length. So this 12.31 looks like it's bigger than 7. So it makes more sense because 132 degrees is greater than 25 degrees. So your answer for number 1 is 12.31. Okay, moving on to number 2. Okay, so we're going to have another triangle this time. And this time we're going to possibly have an ambiguous case. So, let's see. So we're looking for C again, side length C. And you're given angle A is 15 degrees. Side length A is 11. And side length B is 14. Okay, so let's draw this again. A, B, C. 11, angle A is 15 degrees, B is 14. Okay. So now you're looking for the side length C, which is here again. This is angle C. And you're given these two side lengths and the angle opposite one of them. And when you have this situation, you have a possibility for an ambiguous case. Or this is the ambiguous case where there could be more than one solution, or no solutions at all to the triangle. So we're going to have to see first if there's two solutions, one solution, or no solutions. So the way to do that is to find the height of this triangle, which is perpendicular to the base. And to find this, we have a formula which says the sine of 15 degrees, because that's this angle here, times the adjacent side, which is 14, is going to equal to our height. So height is equal to this, which is 3.62. 3.62. If you plug it in to your calculator again, and that will be height is 3.62. And the rules for the ambiguous case say that if the side opposite the angle that you're given lands between the height and the other side, this B over here, if it lands between the two, then you have two solutions. So now one solution is where you have this regular triangle here, and a second solution is where you have a triangle like this, with this side length, this one, and this one. And there's a whole theory behind that, but You're going to have to look in the textbook for that. So the first triangle case, you want to solve as you would like you did up here, where you do law of sines. So you want to find this angle here. This is angle B. So sine of 15 over 11, which you're given, is equal to sine of B over 14. So then multiply by 14 on both sides, and sine of B equals 14 sine of 15 over 11. Then B equals the arc sine of 14 times sine of 15 sine of 15 over 11. And if you plug that in, you get approximately, where's my calculator now? You do arc sine of 14 times sine of 15 divided by 11. You get 19.23. So the angle B is 19.23 degrees. So this right here is 19.23 degrees. And then that's the solution for angle B in one case. And in that situation, you can find the third angle, which is going to be 180 minus 15 plus 19.23, which is 145.77. So 145.77. So in case 1, C equals 145.77 degrees. So side C is going to be equal to, you have to apply the arc sine formula again, where you have sine of 15. You want to do 11 over sine 15 is equal to C over sine of 145.77. And C is equal to sine of 145.77 times 11 over sine of 15, which is equal to 23.91. Okay. So that's one answer you have now. So C is, in case 1, C is equal to 23.91. Now, there's an answer choice which has just that, but we know that's not true because there's two solutions to this. So you can mark that off, and you can mark off any solution that doesn't have 23.91, which will leave you with answer choice D. Well, no, actually that's not true either. So really you're only left with answer choice C at this point, because you know that at least one solution exists. There's actually two solutions that exist, this one and the one you could solve for, which I'll do in a second. But using process of elimination, you can conclude that it's C, answer choice C. And if you want to solve for the other side, you'd draw this triangle right here. This would be an isosceles triangle. So this angle is equal to this one from isosceles triangle theorem back in geometry. And then the supplement of that would be this angle, which is 180 minus 19.23. And that's 160.77. And then you find that the angle C in that case, which would be 4.23, and then you do the law of sines again to find that. But at this point, you would have both cases solved, and you would get that the second side is 3.14, the second C. So now we move on to question 3, because that's what comes after 2. Question 3 is a bit simpler than question 2, in that it only wants to know the number of solutions that are there. So you can draw that triangle again. You have side length A is is 9.5, B is 11.6, and angle A is 39 degrees. So again, draw your triangle, 39 degrees, 9.5, and then B and C, 11.6. Now they want to know how many solutions exist. So really, you want to check if there's an ambiguous case or not. So you have to find this height again, which is perpendicular. If my drawing doesn't do justice, I'm sorry. But it's perpendicular, and it's the height. To find the height again, you do sine of the angle times this adjacent side, which is 11.6, and that is approximately 7.3, looks like. So 7.3 is your H. So this A and this is B. So A falls between the height and the base. So you have two solutions. There's no bubble in, but you just write two solutions. That's your answer. Here we go. Question 4. So now we're going to be applying one of the two area formulas that we learned this chapter. So you're given triangle ABC with an area which is equal to 11.13. An angle A is 68 degrees, and side length B is 8. And you want to find C. Okay, so the area formula, when you're given one angle and a side that isn't opposite that angle, is going to be area equals sine of angle, just any given angle, this is just a generic formula, times the two side lengths that you're given. If you're given two side lengths, not specific yet, that's the formula. So now they're giving us selective information, which will let us manipulate the formula. So area is 11.13, so 11.13 is equal to sine of the angle, so sine of 68, times the B that you're given, which is 8, and C you don't know, so you only have one variable in this, which makes it easy to solve. So C is, you're going to divide both sides of the equation by sine of 68 times 8, so C is 11.13 divided by sine of 68 times 8, and that gives us 1.5. Let me just check that. Yeah, 1.5, and that'll be C. So C is equal to 1.5. Okay. I'm gonna get the back side of this paper. Maybe start again with question 5. And okay, so you have this. So you have this triangle here. This is a dotted line, and you're given this values at 160. And that's about it. Okay, so they have this plane that starts here, and it flies for 160 miles in this direction. And this is conveniently the x-axis. And then they say it took a turn at a northward turn at this point, 27 degrees east, and then ended up heading in this direction. Then they had to turn back and took the shortest route back. So that made this triangle. And you want to find this angle through which it turned, which is the supplement of this angle here. So they call this theta.